In this video I want to talk a little bit about stress in the material and how stress is released as you machine it. So I was machining these parts over the weekend that I'll show with a picture in the video here, and I almost got into trouble because I was doing a certain thing, and then when I continued with the process, the stress was relieved and it ran out quite a bit. And I was experimenting with a newer way of doing it here on the lathe. So let's go over to the lathe and I'll show you what I mean. Over here on the lathe, this part, I machined the first 6 parts and I didn't rough this out here until after I did all of the finished work out on the end. Now here's the solid bar. Now I've just roughed off this OD and that was running true. And now I roughed this notch and this undercut out of the OD, and look at how much it's running out now. And this is before I drilled the holes, the hole in the end of the part and everything. So we're going to check it after we drill the hole and rough the ID and see what we're left with. But the first part I made, which is over here on the, well, it's over here. This is my first article piece. When I machined this, I roughed this out after I finished all of this ID work. There on the ID, and it when I put I noticed it was running out when I roughed off this out at the end here. Unfortunately, I left enough stock to clean this up. And when I put this indicator on here, this was running out 20 thousandths of an inch out here on the end of the part, and I had to actually shim back in these jaws with shim stock because this chucking method holds the part so secure I couldn't, no matter how hard I hammered on the end of this part here, I couldn't move it. So I actually shimmed between the jaws here and got it running true on the ID again over here, and then I was able to finish the OD up to here. And this run out that's going to be back here on that first part is going to be machined away anyway, because this is all just roughed out and there's plenty of stock there to machine away. So this is the run out before we drill and rough the ID. Like I say, I almost got into trouble on this first part because I did everything. Well, I hadn't finished this OD, but I did everything on the ID, and if I had just left it alone and machined the OD, it would have ran out 20 thousandths of an inch compared to the ID. So the reason I left this stock here was I was concerned about the rigidity of the part when I go in to do this coarse thread, which is 6-pitch buttress thread in here, and I was concerned that I'd get chatter. So we're going to see what happens on this part. But what was odd was I ran all 6 of the first part. This guy with the air hose here, it's like a 150 decibel air hose. And we're going to see what happens running it this way. And if I get chatter, I've left plenty of stock here to skim this OD, and I'll have to mount this steady rest here on the. That's the mount for the steady rest right here, this steady rest, and I might have to do that, or I might have to clamp something around the part here to damp out vibration if I get problem with the thread. We're going to see. Not too much change after drilling the first hole. This is a two-part procedure. Drill part way up and rough the hole bigger in diameter and finish the hole, because it has to come up to here and clear this holder. This holder goes all the way into the hole about this far. I'm going to try to show you a process that I think is unique to the Mazotrol control, in that you can stop the machine and save tool points and return to the same roughing cycle or milling cycle, it doesn't matter, and not have to interrupt and reset and cut air. So on this is a first pass on this boring bar, and the shavings will all get loaded up unless we stop it at about 1.25 inches here and bring it back out and then restart it. So I'll show you what this procedure is when it gets down to there. We go to about a little less than 2 1/4 right here. Push feed hole here, and then on this machine you push it into manual mode. Turn the coolant off if you want, and then over here you push tool point save, and you'll notice right here it shows 1 point. Then we're going to go to jog the x-axis. It's already there, and in the maximum rate is fine. And we're going to jog down a couple of clicks, and then we're going to switch it to the z-axis here, and we're going to jog out a little ways, and then we're going to set another tool point save. See, now it's got 2 points, and then we're going to jog it out all the way so we can get to the machine to clear the shavings in the bore. I'm going to set the camera down here because I got to do that to open the doors. You get a light. There's usually a bunch of shavings packed up in the bore. See them back there? So I got to get those out and check the insert. Insert doesn't look too bad, and then we can restart the machine. So the shavings are out of the bore. Now I'm going to set it back down here, and we've got to close the doors, put it back into the memory mode here. And on this machine it has these safety doors, so I have to close them. Now notice we've got 2 points here, so I'm going to set the rapid down, say to about 10%, so we can see what's happening here. When I push cycle start, it starts the spindle and it's going back in. Now it's stopped, and it's got 1 point to go now. Now from this point to the second point to the first point, it's going to feed at the program feed rate. I'm going to turn the coolant back on, cycle start. You notice it's feeding. Well, it's already did it, but because if you make the first 2 points very short distance, it doesn't have to feed a long way to get to its target point. Otherwise, if you make the first 2 points real far apart, it has to feed at the program feed rate for quite a ways. So that's something that I think is unique to the Mazotrol, and it works both in the turning and milling operations. Make sure everything's okay with the tip of the drill here. Particularly looking for wear on this drill tip right in this area, because this is where it wears out. To look at another one. don't know if you can see it, but see where the wear, because I'm running kind of a high surface footage, so the tip will wear out right there, right in here. So that's what I'm looking for here, and as well as just looking at the inserts in general, make sure they're all right. That looks good. This is what it normally looks like through the window of the machine. That's the load on the spindle here. About 40, almost 50%, 240 RPM, 5 thousandths per revolution feed rate. And the Z-axis load up 30, almost 40%. Bored out part of the bore. And then we're going to come in with another bar, because this one will hit this part of the bar if it goes up in the bore in any bigger diameter than this. But let's see what the runout's done. It actually might have slightly improved the runout, boring that out. So now we're going to come in with the next bar. That's an offset bar, so we can go right up to the major bore diameter and see what that does. This is what the next bar looks like. We put a fresh insert in the tool, but you see it can come up all the way and clear the bar. This bar is going to be the one to take out the very last amount of this the step in the bore over there. It's the taper down to the end of the bore. Okay, that's the taper board in there. Let's check the runout, see what's happened with the runout. Looks like we got about 7.5 thousandths of runout. The next tool is this 1-inch carbide end mill, and it's going to rough out the way down in the bottom. There's a 1 3/8 counter bore. It goes 2.5 inches deep. And this is the final bar here that did the roughed the bore all the way back, and we roughed the counter bore with the end mill, and now the whole ID is roughed out. Let's see what the runout's like now. Looks like it's we ended up being about 7.5 thousandths. So here's the runout after the whole ID is finished machined. It's about, what are we getting, about 7 thousandths, 7.5 thousandths of an inch. And the whole ID has been finished machined at this point. Let's talk a little bit about stress in materials and why it's there, and what the cutting tools actually can introduce stress as well. First of all, any round bar, flat bar, or anything, when they form it in the mill, the rollers compress the surfaces of the material. In the mill roller, whether it's a plate or a round bar. Round bar, of course, is all the way around the OD, and on a plate, it's on the faces. Usually, it's where it's being formed. Or a square bar or a rectangular bar, it'll be on all 4 faces. And if it's hot rolled, it's got less stress in it than cold rolled. Cold rolled has more stress, of course, because it's cold worked on the surfaces with tremendous, pressure. So these compression on the surfaces, and then it kind of diminishes as it goes into the bar or plate or whatever, and so it's less in the middle. So if you're going to machine something and you want it to remain as flat as possible, it's a good idea to take an equal amount of material off both faces of the part, or well, a round bar, you're of course going to take it right down the OD, and it's going to be equal if you're turning it in the lathe. So it's not going to be as big a problem in the lathe. But in the case of what I was showing in the beginning of this video, it's the bars that I have must have an unequal amount of stress as it goes down towards the center, because I'm having difficulty when I cut this undercut in the OD here and get close to the center. It starts to distort the bar out of straight, so it can be unequal as well, but usually it's pretty much even. And so if you're facing in the mill, you try to take an equal amount of material off both faces of a piece of plate, whether, you know, of any material, whether it be aluminum, steel, or whatever, and it'll help you keep the plate flat or flatter. And it's not really a guarantee of anything like I saw with these round bars. And I think the reason the first part distorted so much was because when they roll these, you know, if you get a long rod and you roll it through the mill, where they start the rollers and where they come off the bar, there introduces more stress in the ends of the bar, so that piece may have been cut close to the end of the bar, the round bar, and it had more stress in it. And a lot of times if you get just like hot rolled material, it'll be kind of distorted at the ends too, and you have to actually just saw them off because you can't use them right at the end. But also there can be stress introduced in the machining process with a cutting tool. You know, if you come across the face of a part, I'll just draw an inserted tool here with like a face mill or something. It's actually pushing material into the part as you cut off the face, and introducing stress in the face of the part, and it can actually warp the part to exaggerate it up towards the tool. In the most extreme cases, you know, you can even have your tool dig in on the back side here, because, you know, if this is a face mill and there was inserts all around, you know, this side too, you can actually have it dig in the back side, because as it comes across the face of the part warps up into the tool. A carbide insert, if you magnify the cutting edge of a carbide insert, let's say this is a big magnification, they generally have a micro chamfer or grind, or a radius even, right in the cutting edge. And it's intentionally designed in a carbide tool to be that way, because, or an insert mostly, because the cutting edge of a carbide tool is very fragile, and this increases the strength of it and increases the life of the tool. On an end mill is much sharper cutting edge, and it'll generally put less stress on the part if you're facing the top of a part, but it takes longer to do it. So there's a trade-off in time, and so you got to decide, you know, can I spend the time, or is it necessary because I have to hold a certain flatness or something like that, you know, of the part. And like I say, if you have a piece of material and you cut mostly out of one side of the material, when the material's formed, there's a compressive force in the surface that's pushing out towards the ends of the material, because this surface is compressed when it's milled, and if you cut into it and relieve it, then this bar is going to warp this direction like that, because this force is pushing out and you've cut into it. So these are the possible reasons that you can have distortion in the bar, and it'll be less pronounced in the center, like in the case of when I was showing in the beginning of this video, when I drilled and turned, it distorted the part less than this cut on the outside did, because I relieve this some kind of stress in the bar right here. So these are things that can happen when you're machining. You got to take them into account, and it can be even in big thick pieces of material. This can even be more severe actually than in smaller pieces. I've had big thick pieces, 4 inches thick, and I would cut a notch. Like I had this part I was making that was it was a stainless steel block of material that was it was like 4 inches thick here, and it was, I think it's about 8 inches by 12 inches, and I had to cut this notch out of it like this, and believe it or not, that notch there distorted this side of the piece all the way over here just by cutting that notch out of it, as well as here. So I had to rough that out first in the part before I could finish milling these outside surfaces, because there was, in this case, it was a critical that they were flat and a square and a squareness here. So it's not necessarily small parts. Large parts, this actually is more exaggerated in larger parts than small parts because there's much more force in the material. This also was made out of forgings, which can have a lot of stress in them too, depending on how the material is heat treated and stress relieved. But stress relieving doesn't solve all problems always. So this is I was just showing a little issue I ran into where I machined 6 of the parts and didn't have any trouble. But then all of a sudden I had trouble with the other parts. Maybe they're cut out of a different bar, I don't know. Or maybe a slightly different heat treatment process maybe. So you need to be aware of this when you machine and plan for it, because it will happen no matter what you do.